Welcome to Quick Learning. Today we are going to learn the next phase of DMAIC project, that is MEASURE. MEASURE phase is basically used to measure the current process performance. There are multiple story components of MEASURE phase. So we will discuss these. First we will have a brief overview of all of these, and then we will discuss each of these separately in detail. So number one is we have to create a detailed process map. Then we have to identify value added and non-value added steps. We have to develop the data collection points and the data collection plans. Then we have to collect data. Next step is the defect data over time needs to be plotted in a chart. Then we have to assess the process performance in some control charts, the upper control limits, lower control limits, etc. Then we have to stratify the data in maybe frequency plots or the Pareto analysis, Pareto charts. The next is the performance calculation, the yield, defects per million, sigma level, etc. And the next phase is the process performance need to be set to achieve the improvement goal. And the last step is the development of final problem statement. So all of these steps were being done to actually define a focused final problem statement that needs a complete data measurement and data analysis to define a problem statement. So in this way, this is the summary how the measure step of DMAIC project is being done. So we will start from the first step. The number one, it is detailed process analysis. First we have to draw a process flow diagram of a process. Then we can draw it on any different softwares, and then we have to categorize it, whether which portion comes in which category. For example, in this complete process that is drawn on left side, there are four major stakeholders. Number one is sales, then technical, shipping, and coordinator. So in this way we are able to define the four stakeholders in this process analysis. Let's have an example of a water map for a process line. It starts from the turbines. We have three turbines, then raw water collection header. After that we have raw water two tanks of each of 100 meter cube. Then we have discharge header. After that we have ultrafiltration. There are two ultrafiltrations of 112 meter cube per hour. Then ultrafiltration storage tank. After that we have activated carbon filters. There are four filters, each of 56 meter cube per hour flow capacity. Then we have RO, reverse osmosis, two ROs, each of 100 meter cube per hour. After that we have storage tanks, then booster stations, ultraviolet sections, and the last one is treated water discharge header. And from this header there are six lines that are going to production areas, syrup room, boiler, etc. So we have multiple utilities that are connected, like for example from raw water discharge header we have utility ultrafiltration, where we have arsenic arsenic removal filters. Then we have again discharge header, WSP headers, soft water storage headers, and there are this water is going to some other sections as well. So this is the complete process map of the water section in any beverage factory, that how water is being taken out from the ground and how it is being processed, treated, and it's being given to the relevant production areas. So then we have the data in terms of numbers, what we have measured. For water from well is 1.3 million liters, and it is being divided into three categories: treated water, soft water, and raw water. Raw water is the water that is being used as it is, that was drawn from well. Then we have soft water after less treatment, like after ACF, it's a soft water. And then treated water, that is coming after RO. So the major volume is going to treated water. The treated water is going to product, RO reject, sanitation, stand, filters, etc. Soft water is going to rinsers, cooling waters, washers, cleaning, etc. And raw water is going to gardening, sand filter, wastewater treatment, restrooms, garden pool, etc. So this is the complete bifurcation where this water is being used. Then what we will do is what we will have a Pareto chart that will be drawn based upon the consumption of different areas. So this chart shows that RO reject is having maximum consumption, then sanitation. Next one is garden irrigation, rinser, cooling water. Then all of these are contributing towards around 100% consumption of the water. In percentage, you can see that RO reject is consuming 24% water, 11% water is being consumed by sanitation, garden irrigation is taking 9%, and so on and so forth. So this Pareto chart gives us an understanding that what are the major consumption areas where we need to work on. So in this phase we get the idea what are the major high consumption areas. Like here we can see that these three areas consume more than 50% of the water. So these are the major consumption areas and we need to work on these. So we will continue our lecture in next video. Until this slide, if you have any question, you can just write in the comments tab. Please like and share this video, subscribe to our channel. Until next time, bye bye.